Hello everyone, welcome to our next lecture on operating system. In our previous lecture, we looked at process scheduling, and we noticed that uh, processes are selected from a pool of jobs and they are kept in the ready queue. The processes in the ready queue are the processes which are ready to execute, and these processes are selected. Some of these processes will be selected using a particular criteria assigned to the CPU for execution. Now, the criteria for the selection of the processes to be sent to the CPU for execution is what we call the process scheduling algorithm, which brings us to our lesson of today: operating system scheduling algorithms. Now, there are several scheduling algorithms. We have the first come first serve scheduling algorithm, which is done on the first come first serve basis. Shortest job next scheduling algorithms, which is done on the shortest job first basis. The priority scheduling, shortest time remaining round robin multi-level queue scheduling. Let's start with the first come first serve scheduling algorithm. The jobs are executed on the first come first served basis. It is a non-preemptive algorithm, which means that the jobs will actually execute until their burst time is complete. Right, will actually execute until their burst time is complete. Now, it is easy to understand and easy to implement too, but it has poor performance because the wait time is generally high. Let's look at an example. Now, let's calculate the average wait time of the following processes using the first come first serve algorithms. Right now, we have on the first column processes, second column burst time, then arrival time on the last column. Now, observe something before go ahead. You see that process 1 enters the ready queue at the second time instant. Process 2 enters the ready queue at the fifth time instant. Process 3 at the first. Process 4 at the 0th time instant. Process 5 at the fourth time instant. So the very first step we do is to put down this table exactly as it is in the equation. Then the next step is we rearrange the processes according to their arrival times. So that is why you see on this last column, on the arrival column, we have it in ascending order 0, 1, 2, 3, because we have rearranged all of the processes in according in the arrival time. Process 4 arranged arrived at the 0th time instance, so we'll put it at the very top of the table. Process 3 at the first time instant, just in that manner. Next, we calculate the service time. The service time is the cumulative addition of the burst time starting from 0. So we first of all start from 0 and then we cumulatively add the burst time to it. So first we start, the very first process is for 0. Next process we add the burst time to 0, which is what, 3. Next process we add the burst time 8 to 3, which gives us what, 11. Next process we add the burst time, which is what, 6 plus 11, which gives us 17. And the last we add 4 to 17, which gives us 21. That is the service time. The service time is the cumulative addition of the burst time starting from 0. We take it all over. So we start by putting 0, right? And then we add 3 to 0 to give us the next. We add 8 to 3 to give us 11. We add 6 to 11 to give us 17. We add 4 to 17 to give us 21. Or better still, we could put 0 and 3 plus 0 give us 3. 8 plus 3 will give us 11. 6 plus 8 plus 3 will give us 17. 4 plus 6 plus 8 plus 3 will give us 21. That is the service time. Now let's calculate the wait time. The next step, you see, the next step, that's the 4, is to calculate the wait time, because the goal here is to get the average wait time, right? The question was what? Calculate the average wait time for the following process. So now we have to calculate the wait time for each of the process, and wait time is of the process is the service time minus the arrival time. Now the service time of process 4 is 0, and process 4 arrived at the 0th time instant. So what? 0 minus 0 to give us 0. Process 3, the service time for process 3 is 3, and process 3 arrived at first time instant, so 3 minus 1 give us 2. The service time for process 1 is 11. 11 arrived at the second time instant, so it give us 9. Same thing, 17 minus 4, 13, 21 minus 5, 16, right? Process 5 has a service time 17. It entered at the fourth time instant, so we have 13. Process 2 has service time 21 and entered at the fifth time instant, so wait time is 16. Now we calculate the average time by adding they will calculate the average wait time by adding the individual wait time and dividing by the total number of processes, which is 5. That will give us 8. Next, some common questions you may be asked is to maybe draw the Gantt chart. Now, to draw the Gantt chart is a horizontal bar chart which demonstrates the arrival or scheduling time of the various processes. Now, it will look something like this. For first come first serve basis, we normally arrange the processes at the instant of their arrival. Process 4, process 3, process 1, process 5, process 2, and the boxes below indicate the burst time, right? Each box indicates a cycle of execution. Now process 4 executes a burst time of 3 cycles. That's why we have 3 boxes assigned to process 4. Process 3 executes a burst time of 8 cycles. That's why 8 boxes assigned to process 3. Now, since it's first come first serve basis, at the 0th time instant, process 4 arrives and executes at the burst of 3. So at this time we see that process 4 has arrived and has executed for 3 cycles, so we'll say process 4 executes for 3 cycles. So process 4 executes for 3 cycles, right? But now we have to understand that this algorithm is what we call a non-preemptive algorithm. Now, a non-preemptive algorithm is an algorithm that will execute once a process starts, it executes to completion before another process takes over. That is, it completes its entire burst time. So if process 4 starts, it's going to complete its cycle of execution before releasing the processor to another process. Now, so this is an example of a non-preemptive algorithm, or an algorithm without preemption, or an algorithm without preemption. Now, so let's demonstrate the Gantt chart. We've seen that the arrive time process 4 arrives at the first time instant, process 4 at the 0th, process 3 at the first, process 1 at the second, process 5 arrive at the fourth time instant rather. So process 5 arrive at the fourth time instant, and process 2 arrives at the fifth time instant. So we have process 2 there at the fifth time instant. But all of this is just to show when they arrived. Now let us see what happens when they start executing. So at the 0th time instant, process 4 arrives, and process 4 has a burst cycle of 3. So process 4 executes for the first 3 cycles. Right now, the next we have process 3, which has a burst cycle of 8. So process 3 will execute for the next 8 cycles. Next we have process 1. You see that it's actually following the order. After process 3, after process 4, we have process 3. Now we have process 1, and process 1 has a burst cycle of 6. Then process, let's skip a cycle, but the next process to execute is what? Process 5. So at this time the process is idle, right? So process 5 will start here and you execute for 4 cycles. So 1, 1, 2, 3. We have to add 1 there, here. So that will be 1, 2, 3, 4, 5. Great. So that will be idle since there is no time instant, and then process 5 will actually start here and execute for 4 cycles, right? Great. And then lastly, we have process 2, which comes directly after process 5 and executes for 3 cycles. Okay. Oops. 3 cycles, sorry. Yep. There we go. Now that is how we do first job first come first serve algorithm. Now let us look at the next algorithm, which will be shortest job next. So let's continue. Just like the shortest job first, just like the first come first serve, we'll move on now to the shortest job next algorithm. Now this is known as the SGF or SGN. Now it is a non-preemptive and a preemptive scheduling algorithm. We are going to look at the non-preemptive part of it, and then also the preemptive part of it. Now, the best approach here is to minimize the waiting time. It is easy to implement in batch systems where the required CPU time is known in advance, and it is impossible to implement in interactive system where the CPU time is not known. The processor here should be known in advance, so that we can know how much time it will take to process a particular process. Now let us take for example this let's take this let us solve this example where we'll have just the arrival time and the execution time. Okay. Now, so let's say we are calculating the average wait time using the shortest job next algorithm without preemption, and we draw the Gantt chart. We are given this table with processes arrival time and the execution time. The very first step we do is to copy the table exactly as it is on the board. So we have this. Next is we rearrange the table according to the shortest job, because that is the criteria, the algorithm criteria, shortest job. So we rearrange according to the shortest job, and the shortest job will be determined by the shortest time of execution. Right now, we see that the shortest job here is P1. We see that the shortest job here is P1, but P1 has P1 arrives at the time interval 1. You see, right? So it comes after process P2. It means that at the very first interval 0, even though process P0 has a higher execution time, but it occupied the processor before processor P1 came in. That is why we have processor P1 coming after process P0. Then next we have process P3, which arrives at the third interval, but it has a lower execution time 6. That's why it comes before, or we arrange it later, come before process P2, which arrived at the second interval, but it has a higher execution time. Now next we calculate the service time. Remember, we said the service time is the cumulative addition of the burst time starting from 0, right? So first we put 0 in the service time, then we add we perform the cumulative addition of the burst time. The burst time is also known as the execution time, right? So the burst time is also known as the execution time. Now we will take 5 plus 0 to give us 5, 3 plus 5 to give us 8, 6 plus 8 to give us 14, and we have the service time. I'm sure one of you asked that question before. That there is your answer. Now to calculate the wait time is what? The service time minus the arrival time. So the service time here is what? 0, and arrival time is 0 for each of the processes, and that's what we do. 0 minus 0, 5 minus 1, 4, 8 minus 3 for process 3, we have 5, 14 minus 2 for process 2, we have 12. Then the average wait time, we add each of the wait time for the processes and we divide by the total number of processes, which is 4, to give us 5.25. Now to draw the Gantt chart, the same principle applies, but this time around we are dealing with a non-preemptive algorithm. So for non-preemptive algorithm, this is how it's going to work. First, when process 0, first we start process 0 takes since process 0 enters at the 0th time interval, process 1 at the first time interval, process 3 enters what process enters? Process 2 enter the second time interval. So it is process 2 enters at the second time interval, and process 3 enters at the fourth time interval. Now first, when process at the 0 time interval, you see that there is no process, right? So process 0 takes the processor and executes for its 5 cycles of execution, right? Remember, process 0 has a burst time of 5, so it means it executes for 5 cycles. Process 1 execute when process 0 has entered, you see that it has executed for its 5 cycles, but this time around other processes came in during that period. Process 1 came in, process 2 came in, and process 3 came in. So at this moment in time, the processor will have to check these 3 processes and select the shortest job out of these 3 processes to execute first. So process 1, process 2, process 3, let's look at it. Process 1, process 3, process 2, we have 3, 6, 8. The shortest job here is the job with the execution time 3, and that is process 1. That is why process 1 will be executed first among the first 3, and it will execute in its 3 time cycles. Next we see that 2 processes are left, process 3 and process 2. We are going to check the 2 processes and see which one has the shortest job. We have process 3 and process 2 with execution time 6 and 8. So you see that process 3 has the shorter job time interval, so process 3 will be executed first before process 2. So the 6 time interval of process 3 will be executed first before process 2. Now process 2 will obviously just execute because there is no other process to compare it with. And that is the Gantt chart for shortest job first without preemption. Now let us look at let us see how the Gantt chart for shortest job first for a non preemptive for a preemptive algorithm, shortest job first, which is preemptive. Preemptive. How is it going to look like, right? Okay, so let us see that now. Now, looking at the non-preemptive algorithm, non-preemptive part of shortest job next, or shortest job first, we see that it is almost the same thing, but for the fact that the job could be interrupted and a shorter job takes the place of a current running job. Right now, we notice that what happens is that process P0 has a longer a longer execution time than process P1. That is why in the non-preemptive part, process P0 starts and uses the processor to the end before the shorter job and came in and respected the algorithm. But in this case, at this level, at the 0th time, since there's only process P0 which is in the ready queue, that process P0 is going to be sent into the processor and it will start its execution. So it's going to run for one time interval, right? That's why it takes this one block. We are using purple here to represent process P0. It takes one block, and then now you see that it has already executed for P0. P0 has already executed one block, and then it remains, it remains 4, right? Now let's go now to, you see that it remains 4, but we will now compare this 4 with the value of process P3. Now we'll compare 4 with process process P1 rather. Process P1 has an execution time of 3. You see, right? So process P1 has an execution time of 3, which is still smaller than than the 4 remaining time units of process P0. That is why process P3 is going to come into the processor and preempt process 0, right? So it's going to stop process 0, and then process P3 is going to sorry, this is this what process that, let me check it up. Process 1 is rather process 1. So process 1 is going to take over, right? And then this process 0, sorry, process 1 is going to take over and then execute its 3 times circles. Now the remaining time intervals, we see that we have what? Process 0, which is 4, process 3, which has time interval of 6, and process 2, which has time interval of 8 units, right? So what does that mean? This means that if we compare now, we see that for process 0 with the with the execution time of 0, with the execution time of 4 is smaller than process 3 with the execution time of 6, and is equally smaller than process 2 with the execution time of 8. That is why process 0 will take the processor immediately after process 1 has finished executing. Because you see now that at this level all the processes had already come into the ready queue, right? So process 0 will take over the queue and execute for 4 seconds, making plus this cycle which completes its 5 cycles of execution. Then process 3 with 6 cycles of execution will take over, and finally process 2 with 8 cycles of execution will finish up. And that is how the preemptive algorithm for shortest job next works.